This is section 4.7. Inverse trig. Now, inverse trig's not that difficult. You just have to remember a few key things. Now, with the inverse trig, we need to remember a few things. We have certain restrictions. So let's first talk about the first restriction. And this is in your notes. And it deals with sine and tangent. With sine and tangent, we have a restriction of they can only be in the first and fourth quadrants. So this second and third quadrant is kind of like a no-fly zone. We can't go into either one of those quadrants at all. We can't go over the y-axis ever. So this is for arc sine of x and arc tan of x. And again, the reason is when we graph the inverse of either sine or tangent, we end up not having a function. And so we have to restrict our domain to get that function. Now if I'm talking about cosine, cosine's a little different in the fact that our restriction is not with 2 and 3 this time, but it's with 3 and 4. We can't go into either one of those quadrants. So this is when we have y equals arc cosine of x. Now the arc part is just a fancy way of saying to the minus 1 power. Arc sine, hold on here, arc sine of x is the same as saying sine to the minus 1 of x. And you've seen that notation, sine to the minus 1, cosine to the minus 1, back when you were in geometry and you were finding the angles using your inverse trig. It's the same thing. We're going to be looking for the angle. So there, for most part, there's not going to be a lot of calculations to go with. So let's start doing some practice. Now I noticed that when I wrote out the notes, I wrote 2 examples, and then I went to do all the other examples and I restarted the numbers. So I'll do the same exact thing on here. So let's look at our first 2 examples. I want to evaluate the arc sine of 1/2. Now when you're asked to evaluate something, you're just trying to find what is this equal? What is the value this is equal to? Now the arc sine of 1/2 means I want to find where sine is equal to 1/2. So the first thing I have to do is this. I have to decide if this number right here, can I have it? Can I have a 1/2? Well, we have to go back to our sine, and sine has to be in between -1 and 1. Now is 1/2 in between those two values? Absolutely. So we can't have this. If this had been like -2 to 3 halves, we could not do this. It would not exist. So we have to be careful. So the first thing we have to do is make sure that that can happen. And really what we're asking you to find is, I want to find where is the sine of theta equal to 1/2. That's what I'm looking for. So if I go back up to my original picture up here, sine of theta is equal to 1/2, well that's the first quadrant. Where is sine 1/2? What angle is that? And that's going to be pi over 6. So this whole thing is arc sine of 1/2 is equal to pi over 6. Now let's do number 2. So yeah, we're already done with number 1. That's it. We're just trying to find the angle that makes that value, that 1/2. And we're not going to have more than just one. We're only going to have one angle when we do inverse, because we have that restriction. We can't go into different parts of our circle. So let's look at arc cosine of -2. Again, the same thing. This is our x right here. And as -1 is less than or equal to -2, it's actually equal to 1. Is this true? No, it is not. So this can't happen. So because this can't happen, we say that arc cosine of -2 does not exist. Okay, so those are the first two examples. Let's go on to the next ones, and I'm going to switch the screen to the next page, and let's get started. So let's do some more evaluate. So we're going to evaluate the next few, and I'm going to restart that numbering. I want the arc cosine of 1/2. Again, we look at that 1/2, and is that a possibility? Is 1/2 between -1 and +1? Yes, it is. So we're okay. So in my mind, I'm going to think, where is cosine of theta equal to 1/2? Now remember the restrictions for cosine. It can't go in either the third or the fourth quadrants. Those are our no-fly zones. So we can't go anywhere down here. We have to stay on top of that x-axis. That would put cosine of my theta over here. And that's going to be pi over 3. Number 2. Let's do the arc sine of -1. Okay, so example 2, arc sine of -1. So the first thing, again, is we look at that -1, and is that possible? Can I have a sine, can sine of theta equal -1? Yes, it can. Where is that going to be at? Well, where's our restriction for sine? We can't have it in quadrants 2 or 3. So where is sine -1? Well, that's going to be straight down at 3 pi over 2. Now, you're probably, wait a second. Wait a second there. I just went through the second and third quadrants, because that's going to be first instinct is I'm going to go 3 pi over 2. You can't. You went this way around the circle, but that takes you into the no-fly zone. What we have to do is we can't do that 3 pi over 2. We have to go the other direction. We have to go this way. So that's going to make that negative pi over 2. So again, you have to be careful. Your instinct is going to tell you to go around that circle. You're going to have to force yourself not to go into the restricted area. You have to stay out of it. And so that's going to be the biggest problem for some of you. These problems are not hard. It's just making sure you go the right direction and stay out of your no-fly zone. Okay, for example 3. Arctan of -√3 over 3. Okay. So, can tangent equal -√3 over 3? Absolutely. Remember, tangent doesn't have a restriction. It's tangent of theta can be any real number. It can be anything. So, -√3 over 3 can occur. Now let's talk about our restriction again. Where's tangent restricted? Same place that sine is. So it can't go here or here. So we can't go in that second and third quadrant. So where's tangent negative? Not in quadrant 1, but down here in quadrant 2 somewhere. So we have to go this way. So negative root 3 over 3 is for negative pi over 6. So that's our angle. So we're down in this quadrant somewhere. Okay. Again, making sure we don't go into our red zone or no-fly zone. We can't cross over that axis. As soon as we cross over our axis, we've messed everything up. Okay, so now let's look at compositions. Composition means we're just taking two functions, or a function and an inverse, and putting them together. Couple things to be aware of with our composition is we need to verify that we can have both that angle and we can have that side measurement, or that value. So let's start with, and that's horrible writing here. Let me write it a little bit neater. The cosine of arc cosine of negative 1/2. So the first thing I have to determine is that negative 1/2. Can I have it? Is it a possibility for cosine to be a negative 1/2? Absolutely. Okay, absolutely. So now I have cosine with its inverse. And what's going to happen is when you take a function with its inverse, they cancel out. And I'm left with just the negative 1/2. Okay. Let's look at the next one. I want the sine of arc sine of 3. Same thing, I'm going to look at that 3. Can sine equal 3? Is it between our negative 1 and 1? And no, it can't be. No, that can't happen. So therefore, this whole thing can't happen. So it does not exist. Okay, number 6. I'm just doing some ones where we have functions and their inverses. Tan of arctan of 7. Okay, what about tangent? Can tangent be 7? Well, we just discussed up above that tangent of theta can be any real number. So therefore it can be 7. So I have tangent and its inverse. They're going to cancel, and that leaves me with just 7. Now I just thought about throwing something in here right now. Some of you are probably thinking, oh gosh, what is she doing now? Well, I want to talk to you about something. Let's say I did a reverse. So this is like, I'm going to say this is 6a. We're throwing an extra one in there. And so this would be really cool, a good idea for those of you who are only printing your notes and not actually watching the videos. You're not going to have this one. So those of you who are listening to the videos, you're going to have an extra problem. I want you to do this one. Let's do arc sine of sine of 5 pi over 3. Again, your first instinct is probably going to be just, hey, I got arc sine and sine, I can cross them off. But what I have to do is I have to look at this 5 pi over 3. Is it acceptable? if I could spell today, acceptable. Meaning, is it where I need it to be? Well, if I go 5 pi over 3, that's way down here. Hold on here. No. It's in that fourth quadrant, which is where it needs to be. But I went around this way. And I went in that no-fly zone. I can't go in the no-fly zone. So I need to change that 5 pi over 3. I have to go from here to here. So I can't go counterclockwise, I have to go clockwise, so I have to change my angle. So I have to change that arc sine of sine of 5 pi over 3 to negative pi over 3. Now that this is in the acceptable region, meaning I didn't go across that y-axis, all of this is just going to equal negative pi over 3. So you have to be careful. If your angle goes into your no-fly zone, you got to rewrite it so it never does. So you have to use that reference angle, that coterminal angle that we have for it. All right, so let's continue. Let's do number 7. Oh, this was number 7. What am I doing? I looked at the wrong page of notes. I thought I didn't include that one. I'm sorry. So that is actually number 7. I did add it in there. Huh. All right. Let's do number 8. Now I'm going to go over. Hold on here. Now let's do number 8 right here. Okay. And we're almost through all of our examples. As I said, these are not that difficult. You just have to pay attention to your details. So this time I want arc cosine of cosine 7 pi over 6. Again, we have to check that 7 pi over 6. So 7 pi over 6 is down here. My no-fly zone for cosine is here and here. So it's in the no-fly zone, so I have to put it where in the proper spot. Now the cosine down here in that third quadrant is negative. So I need to put my angle where cosine is negative. And that is up here in the second quadrant. So instead of going all the way to the third, I want to stop at the second quadrant. So I'm going to rewrite 7 pi over 6 to be 5 pi over 6. I want the same angle, but in an acceptable zone. Once I have it in the right spot, my cosines will cancel, and I end up with 5 pi over 6. Okay, so let's look at number 9. So all the rest of the examples are going to involve Pythagorean theorem. So they're all going to be a little bit different than what we've been doing. So I want the cosine of arc sine of negative 3 over 5. Again, first thing I want to check is make sure this negative 3 over 5 is between negative 1 and positive 1, and it is. Now you're probably thinking, well, wait a second, negative 3 over 5 is not one of my special angles on the unit circle, and it isn't. So there's a couple ways to do this, and what I recommend is I'm going to do a u sub. I'm going to make all of this equal to u. So the arc sine of negative 3/5 equals u. That means that the sine of u equals negative 3/5. Now our restriction is based upon that arc. So that means I'm in not the second and third quadrants because it's sine. I am down here in the fourth quadrant. Now remember, sine is opposite over hypotenuse. So that means my opposite side is 3. My hypotenuse is 5. Your hypotenuse can never be a negative number, by the way, because it's a distance. It's your radius. And this is my u value. So that's my angle. Now I have to find the remaining part of my triangle, and I'm going to use Pythagorean theorem. And so 5 squared minus negative 3 squared is going to give me this side squared. So 25 minus 9 is 16. The square root of 16 is 4. So this side is 4. So now if I go back to my original problem, so now I want the cosine, because remember we substituted u in here, of u. Look at your triangle. Well, the cosine is going to be 4 over 5. So it means that this whole problem equals 4 over 5. So you can use Pythagorean theorem to find the missing side of the triangle, and then just do your normal ratio based upon your triangle. Okay, number 10. Same idea. And my problem is having a little bit of an issue right now. So I want the cosine. Did I miss a number? Hold on here. Oh, 7, 8, 9. I skipped 9. So I have 9 and 10 kind of mixed up. So let's go back and do 9. It's the same thing. Same idea. I want the tangent of arc cosine of 2/3. Same thing, can I have 2/3? Yes, I can. I'm going to make this equal to u, so that arc cosine of 2/3 equals u. So the cosine of u equals 2/3. Okay, I'm going to draw my triangle. My restrictions for cosine are for the third and fourth quadrants, so I can't go down here. So that puts my triangle in the first quadrant, where my adjacent side is, and I'm going to erase a little bit of this red here. Oh, that's not what I wanted to do. I'm going to erase a little bit of this red so I can get that number in there. Where this is 2, and then my hypotenuse is 3. So do, again, Pythagorean theorem. 3 squared minus 2 squared. That's 9 minus 4, and that's 5. So this side's going to be the square root of 5. Simplify your square roots if you have to. Now I just got to find the tangent. So the tangent of u is opposite, which is the square root of 5, over 2. And we're done. These are not that bad. The key thing will be getting your Pythagorean theorem correct. Once your Pythagorean theorem is correct, you'll be good. All right, let's look at 11. So sine of arc cosine of 3x. Same thing is we're going to use our Pythagorean theorem. Now you're probably thinking, well, wait a second, 3x, is that between -1 and 1? We're going to assume it is, because we don't know what x is. There are values of x that will put it between that -1 and 1. So we assume it is. Also, when you're giving a variable, always put it in the first quadrant. Makes it easy. Alright, so I'm going to make this equal to u. So the arc cosine of 3x equals u. So the cosine of u equals 3x. Okay, so again, can't have the second and the third and fourth quadrants. And I'm going to erase some of this again before I get going. I have a triangle where cosine is 3x. I'm going to make it kind of big here so you can see it. Well, cosine is adjacent over hypotenuse. Well, this is technically would be 3x over 1. So 3x over 1. Pythagorean theorem is going to be 1 squared minus 3x squared. Well, that's just 1 minus 9x squared. And it's going to be the square root of that. Do not try to do anything with this. Leave it alone. Don't try to square the 1 and don't try to square the 9. You have a minus sign there. You're going to leave the square root alone. Force yourself not to do anything. Because you have that x squared there, that's the problem. This is a difference of squares. They are not, it's not a perfect square where the factors are exactly the same. The factors are different. You have to leave it alone. So that puts this side as 1 minus 9x squared. And that's kind of hard to read there. Hold on. (1 minus 9x squared). Okay. So now with that, we need just to find our sine value. So the sine of u is going to be that opposite side, which is the square root of 1 minus 9x squared over 1, and that's just the square root of 1 minus 9x squared. Okay, so that's number 11. Let's keep going. Almost done, ladies and gentlemen. I wanted to give you plenty of examples of this. That's why this is so long. We're doing 13 examples in 28 minutes. So it's about 2 minutes an example. So it's not bad. But I want to make sure you fully understand how to do each thing. And I'll have different examples of different ways things can happen. So let's look at number 12. We're almost done. I want the cosecant of arc tan negative x over square root of 7. Okay. So, again, let's look at our restriction. This time it's negative. Tangent is restricted to the first and fourth quadrant, so we can't have these two. So tangent's negative in the fourth quadrant. Again, I'm going to make this equal to u. So that's my angle. So the tangent of u equals negative x over square root of 7. Tangent is opposite, so negative x over adjacent, square root of 7. Again, our angle's there in the corner. Our Pythagorean theorem is going to be, this is our hypotenuse, so it's going to be square root of 7 squared plus negative x squared equals c squared. Well, square root of 7 squared is just 7. Negative x squared is x squared equals c squared. So our hypotenuse is the square root of 7 plus x squared. You can't do anything with this. Leave it alone. And so that's our hypotenuse. Okay. Now we're looking for cosecant of this. Cosecant of u. Cosecant is the inverse, or excuse me, the reciprocal for sine. So it's going to be hypotenuse over opposite side. Well, my hypotenuse is the square root of 7 plus x squared over my opposite side, which is negative x. Okay, last example. Yay! I can hear you guys all saying, finally. Last example. This one looks nastier than it is. I want the tangent of arc cosine. Let's clean up this arc a little bit. Arc cosine of m plus h over 3k. Alright, again, this is my u. Cosine, I'm going to make this really big because I want you guys to see everything. Cosine is restricted to the first and second quadrant, so we can't be here or here. So it means my triangle is up here. Cosine, so the cosine of u equals m plus h over 3k. So my adjacent side is m plus h, and my hypotenuse is 3k. And this angle here is u. So let's do our Pythagorean theorem. 3k squared. Actually, I'm going to give myself a little bit more room. (3k squared) minus m plus h squared. That's going to give me equals, and we can say that this is b squared if we wanted. So this is going to be 9k squared minus m plus h squared equals b squared. Now you're probably thinking, well, you didn't multiply out the m plus h squared. Don't do it. You're just going to give yourself a lot more work to do. Square root the whole thing, and you're going to be fine if you do that. You're not going to get marked down. And you get the square root of 9k squared minus m plus h squared equals b. Otherwise you get just this nasty looking thing. And that's this right here. This side is going to be the square root of 9k squared minus the m plus h squared. That's all of that. Now we're going to do the tangent. So the tangent of u is going to give that opposite side which is the square root of 9k squared minus m plus h squared. Uh-oh, what happened? Oh, there it is. Sorry. I have no idea what happened. All over the adjacent side, which is m plus h. And we're done. If we'd ended up with our square root on the denominator, that nasty of a square root, you're not going to be required to rationalize it. Okay? Alright, so this is lesson for 4.7. Have a nice day.